Today we're going to take a look at factoring and finding the greatest common factor. So our title for today is factoring and then greatest common factor. We're actually going to start right here with the blue, and I'm going to review doing a factor tree and breaking it all the way down. And then we'll go through and do some examples where we have to factor using the fact that we found the greatest common factor. Now, a greatest common factor is what number or variables that your terms have in common, and it should be the biggest number, which is why it's called the greatest. So we're going to be looking at 30 and 50, and we're going to be finding the biggest number that they share. And then in the next example, I will put some variables. Now, I'm sure out there we're all at different levels. Some of us can look at these two numbers and say, hey, the biggest number that goes into 30 and 50 is the number 10. And I don't have a problem if you're already there at that level. However, I'm going to show you how to find the greatest common factor by using your factor trees. So we're going to do a factor tree for 30 and we're going to do a factor tree for 50. So we're going to break down to number 30. When you start your factor tree, it does not matter where you start as long as you start with two numbers that multiply to give you 30. So we could do 3 times 10, I could do 5 times 6, I can do 2 times 15. Makes no difference which two numbers we start with as long as you start with two numbers that multiply to give you 30. So no particular reason, I'm going to do 3 and 10. Again, if you want to start out with something else, knock yourself out. Then I'm going to break down 10. 10 is 5 and 2. And I am finished. You know you're finished with a factor tree when you have all prime numbers. So prime numbers are numbers whose only factors are 1 and whatever that number is. So factors of 3, 1 and 3. Factors of 5, 1 and 5. Factors of 2, 1 and 2. All of those are prime numbers. I cannot break those down anymore. If it's not prime, it's a composite number. So prime numbers only have two factors, 1 and itself. Composite numbers have multiple factors. So you know you're finished with a factor tree when you break it all the way down to prime numbers. Now let's take a look at 50. We're going to do the same thing and break down 50. Lots of different options, 10 and 5, 2 and 25, makes no difference. I'm going to do 2 and 25. And I'm going to break down 25 and get 5 and 5. So I have done a factor tree for 30, and I did a factor tree for 50. Now I'm going to circle what they share because I'm looking for the greatest common factor. So I see that there's a 2 here that they share, and I see that they share a 5. So their greatest common factor, which I'm going to put right here, GCF. So their greatest common factor is a 2 and a 5. So their greatest common factor is 10. So you take whatever you circled, that is their greatest common factor. They each share 1, 2, and 1, 5. So you really only have to look at one branch and you'll be able to determine the greatest common factor from there. Do not, I see this sometimes, do not do 5 times 2 times 2 times 5. You're counting your numbers too much. You only count them once. They each have 1, 2, and they each have 1, 5. If they had multiples, then you would multiply, but they only each share the number 2 and the number 5. So regardless, their greatest common factor is 10. Now, let me go through and do one that has variables, and then we'll go to the problems that are written in red so we can actually begin the factoring process. So this is just us reviewing, making sure we know how to find the greatest common factor. It could be a number, it could be a variable, it can be both. If they don't share anything in common, then their greatest common factor is the number 1. All right, let's take a look, and we're going to do 6x to the third y and 18y, and let's throw a square here. All right, I'm going to go through and I'm going to do 2 factor trees. I'm going to do a factor tree for 6x to the third y, and I'm going to do a factor tree for 18y squared. So if I break this down, this gives me 2 times 3. The exponent tells you how many times to write the letter. So this is x to the third, so that is x, x, x. I got 1y, I bring down the y. I'm going to do the same thing over here for the 18. I can do 6 and 3. It's going to be 2 and 3. And it tells me I have 2 y's. So y and y. All right, so let's recap there. This was 6x to the third y. I did my numbers like I did the previous example, break it all the way down to prime numbers. Exponent tells you how many times I write the letter. This was 18y squared. Break it down to prime numbers. Tells you how many times I write the letter. 2 y's. Now I'm going to circle what they share. I see a 2 and a 3, a 2 and a 3, and 1 y and 1 y. And that's all that they share. So their greatest common factor is the number 2, the number 3, and y. So their greatest common factor is 1, 2, 1, 3, and 1 y. Again, you only have to, once you go through and circle, you only have to look at one branch. So I just looked over here. Multiply all of that, 6 times 2 times 3. 2 times 3 times y, excuse me, I was thinking ahead there. We got 6. So 2 times 3 times y gives me 6y. All right. Now that we have found the greatest common factor using the factor trees, we're now going to go back and actually factor. Your first step when you do any kind of factoring is to find the greatest common factor. If it doesn't have a greatest common factor, we can skip that step. However, your thought process when you are factoring should be to find the greatest common factor. So let's go through the problems in the red, and we're actually going to factor them. Now, factoring is doing the box method and distributive property. We're like doing that backwards. So before I would give you the parentheses, you would multiply it out by box method or distributive property. Now we're working backwards. So we're working backwards. All right, so let's start with the first one. I'm going to do 3 factor trees. If you are to the point where you can know your multiples off the top of your head, you can read them off backwards, forward, upside down, then you may can look at each term and determine what number or variable they all share. But if you are not there, that is okay. We're going to do our factor trees. So this is 16x to the third minus 24x squared plus 8x. And we're going to go through and do a factor tree. So here we are. I'm going to do 8 times 2. 4 times 2 and 2 times 2. I have 1, 2, 3 x's. And let me write my x's somewhere else as not to interfere with my second term there. So 1, 2, 3. So I did a factor tree for 16x to the third. I wrote my 3 x's and I broke it down to prime numbers. I'm going to do the same thing with my second term. So this is going to give me, I could do 6 and 4, 3 and 2, 2 and 2. And I got 2 x's, x, x. I'm going to break down 8x, break that down. That's going to be 4 and 2, 2 and 2, and I got 1 x. So far, all I've done is gone through and did factor trees. I did 3 factor trees. Make sure you include numbers and variables. Now I'm going to go through and circle everything that they share, whether that's numbers, whether that's variables, maybe it's both. I'm going to go through and circle everything that they share. So I see that we have a whole bunch of 2's. 1, 2, 3, 1, 2, 3. 1, 2, 3. So they each share 3 2's. This one has 3 2's. This one has 3 2's. This one has 3 2's. So they each share 3 2's. They also each share an x, an x, and an x. So they also each share that. So that greatest common factor is 2 times 2 times 2 times x. So the greatest common factor is 8x. And it goes on the outside of your parentheses. So let's go through that again. After you circle everything that they share, numbers, variables, both, after you circle everything that they share, you multiply it. So 2 times 2 times 2 times x, that is 8x, and that goes on the outside of your parentheses. Everything else is going to go on the inside of your parentheses. So if I get rid of everything that I circled, I'm left with 2x squared. After I get rid of 2, 2, 2, and an x, I'm left with 3x. And I got a subtraction sign in the middle that I'm going to bring down. And I'm left with 3x. After I get rid of a 2, a 2, a 2, and an x, you might think that you don't have anything left, but it's assumed to be a 1 left. So plus 1. So this is our final answer. Now, in the coming days, we'll be breaking stuff down a little bit more, but for right now, we're just finding the greatest common factor. Your greatest common factor goes on the outside, and these are what are called the leftovers. So these are our leftover factors. So we're working backwards. A great thing for you to do is to check your answer. 8x times 2x squared gives me 16x to the third. 8x times negative 3x is negative 24x squared. And 8x times 1 is 8x. So we're doing the distributive property backwards. All right, 2 more. 10x squared plus 20x. I'm going to do a factor tree. So 5, 2, and I got 2 x's. This one's going to be 5 and 4, 2 and 2, and an x. So I did factor tree. Let's circle what they share. I see that they share the number 5. I see they share the number 2. I see they share the variable x. So their greatest common factor is 5 times 2 times x, which is 10x. So 5 times 2 times x is what they share. 5 times 2 times x is what they share. Leftover prime numbers and terms go inside of the parentheses. So after I take away the 5, the 2, and the x, I'm left with an x. Bring your plus sign down. After I take away the 5, the 2, and the x, I'm left with a prime number of 2. Greatest common factor goes on the outside. Everything else goes on the inside. And check your work by just doing the distributive property back out, and it should give you the original problem that we started with. In this case, it'll give us 10x squared plus 20x. Last one, we're going to go through and do our factor trees for this. So I can do 6 and 2, 3 and 2, excuse me, and I have 5 x's. So 1, 2, 3, 4, 5. Okay, I'm going to do a factor tree for here. 9 and 2, 3 and 3, and I got 1 x. And I'm going to do a factor tree for 10, 5, and 2. I'm going to go back and circle any numbers or variables that they share. So looking, I see everything has a 2, 2, and 2. And I think that is it. So they don't share anything else. So sometimes you can have numbers, sometimes you can have variables, sometimes you can have both. In this particular case, we only had the number 2. So 2 is going to go on the outside, and everything else is going to go on the inside. Meaning, what does it take to multiply back to get you the original problem? 2 times something has to give me 12x to the 5th, so 12. 2 times something has to give me 18x. And 2 times something has to give me 10. So if you take away your greatest common factor, everything else is going to go on the inside. So take away your greatest common factor. Left over, I have 2 times 3 times 1, 2, 3, 4, and 5 x's. So 2 times 3 and 5 x's gives me 6x to the 5th. Bring your subtraction sign down. Okay. Take away the 2, what's left over? A 3 times a 3 times an x. That's 9. Take away the 2, what's left over? A 5. And I'm going to sound like a broken record, and in the next coming days, I'm going to say it over and over and over and over and over again. Distributive property, check your work, or box method. 2 times 6x to the 5th gives me 12x to the 5th. 2 times negative 9x is negative 18x. And 2 times 5 is 10. So we're doing the box method or distributive property backwards. But this is factoring. We're finding our greatest common factor. That goes on the outside, leftovers go on the inside. Greatest common factor on the outside, leftovers on the inside.